In my view, Watch is a very important project for both scientific but also policymakers community. Why is that? There are three big components which I think Watch project is going to bring further beyond the current state of the art after this 4 years of endeavor has been accomplished, which will be this summer. First, water cycle. Water cycle is a subject of research of the large global research community. I have been involved in discussions about how to monitor, measure water cycle for the last 20 years at the international level. We know meanwhile that the issue is complicated, and we know meanwhile that we can't really understand fully the water cycle just by measurements, by monitoring, because data are sparse. We also know that the models are not adequate to be able to. We know that we need a combination. We know that the big problem is sitting with the databases, global databases. And Watch has been making big progress in a couple of aspects of understanding of the current water cycle and the past water cycle based on both data and modeling. That's number one. Second big issue is, even maybe the biggest, at least to me, in terms of the framing and defining the questions for Watch project, is the way how the scientific community has been approaching over the last maybe 15 years the issue of the global water resources. Water resources at a global scale, being understood and modeled and monitored consistently, has not been done very well. And until Watch started, the main results about the water resources in the future, subject to climate but also other changes, has been based on a number of almost anecdotal studies. Single model study with its own architecture, no idea about the ranges of uncertainty, no idea about what would happen if you use a different model. And funny enough, until Watch started, this has been also the basis for big discussions about World Water Fora, which I've been part of. We put up a new paradigm when we started to write proposal for Watch. We said this project would provide first ever multi-model based estimates of the global water resources for 2050 and 2100. And this is new because as I said, the water resources issues like how frequent will be droughts and floods, how severe the water shortage may be because of all the changes we are facing, including population change. And we are heading there. We have been successfully able to use a number of global models to actually come to this important exercise. I will come to in a minute. So this is a second big achievement of Watch project. There is also in between an issue of how to deal with the climate scenarios for the future in terms of using those scenarios for impact studies. Certainly when it comes to the hydrological water applications, and of course the project has been very consistent in addressing this issue, and the project has has actually put a lot of energy and effort on the way how the best climate models we have collected in this project are able or unable to get the high resolution climate data in a form and quality that the impact models could use it. Well, I'm talking about necessary corrections which even the best climate model must undergo before you can use the data for impact models. The project came up with a new way of, we call it bias correction, actually after processing the data from climate models to be able to enter the impact models to do calculations. So this is yet another part of the achievements. And there is one more generic, really cutting edge result, I think, in this project. I already mentioned the multimodal based water resources. We call it water MIP, water multi-model intercomparison, and that multi-model intercomparison statements results were based only in the climate domain so far. What I mean, if you go to the IPCC reports, the IPCC assessment reports, you would find this division between working 1 and 2 and 3, 1 being climate system, climate scenarios, 2 being the impact mainly and effects, and 3 of course is the mitigation part of the story. So far, the first category, climate models, has been able to actually rise multi-model type of scenarios with the ranges of uncertainties. So far, until Watch, the group 2 of IPCC had to work with a very incoherent, heterogeneous set of results. For example, if I were to say something about drought in northeast Brazil, I would have to be basing my conclusions on one single paper which somebody just by chance published or not right now. That problem with the working group 2 of IPCC has been already noticed, of course, by all of us, and we have been communicating that problem. And certainly for the IPCC 5 report, there is a community around the world which is called IAV, Impact Adaptation Vulnerability, promoting actively this need for a multimodal, consistent approach comparable to the multimodal ensemble of climate data. And WATCH has been the first project actually showing how it can be done. We call it WaterMIP, multimodal-based impact assessment based on the multimodal climate scenarios put together in a new set of assessment. And I think this is something which will be followed by many. And I think this is going to also mark almost pave a new way for the IPCC Plus. It may not be completely taken up by the IPCC 5 because time is too short, but it will certainly sort of pave the way for a new approach in terms of the IPCC 6 that may come next then. So altogether 4 major achievements which I think this project has been able to put forward and actually show, illustrate, document this is possible.